Hi, folks. I hope you're having a great day. So we've talked about a little bit about quadratic functions and what they look like and where they might come from. So the next few parts of this unit are going to really require us to do some addition and subtraction and multiplication with something called a polynomial. So that's what we're going to work through today. So a polynomial is defined as a mathematical expression containing coefficients, so that's numbers, in front of variables. So coefficients and variables, variables has only one L in it, that involves only addition or subtraction between terms. If you happen to hear a cat, that would be Herbie. He's trying to help you learn today. So, like terms, you've heard this phrase before. That would be the same variable or exponent combination. So something like 3x squared and 9x squared, they both have squareds in them. Those are like terms. Something like x and x squared, those are different. Even though they're both x's, they're a different exponent. So we can't consider those like terms, so we wouldn't combine them. Now, you've already had lots of practice combining like terms. So the long story short is that we either add or subtract the coefficients, so the numbers in front, but we keep the variables exactly the same. So whatever that variable and that exponent combination is, we're never going to change that. It's always going to stay the same. Now, if it looks like the coefficient is missing, so if there's no number in front of the variable, remember we have that little ninja 1 in front to keep an eye out for. And something to keep in mind, which will make a little bit more sense as we look through an example, is that coefficients always take the sign directly in front of them. So whether we see a plus or a minus, that's going to tell us whether our number that we're dealing with is a positive or a negative. So let's do a short example here. We're going to combine like terms. So the very first thing we should do is just practice identifying our like terms. So I'm going to use a couple different highlighters here. So the first bit here is negative 2x, and notice I'm going to include that negative there. Its like terms are negative 4x and negative 15x. So even though there are x squareds, those are different exponents, so we're not going to consider those like terms. Some other like terms, a positive 3 doesn't have any variable with it, so it's a like term with the 5 and the negative 15 and the 11. Oops, I missed the 11 in there. And then finally our squares there, negative 4x squared and negative 2x squared. So notice that with all of these, I'm trying to capture the sign in front of the number as well. So once we know what our like terms are, then we're going to combine by either addition or subtraction, depending on the sign. So maybe starting just with my x's there. So negative 2x minus 4x minus 15x. Again, I just add or subtract those numbers together and I'll get negative 21x. Then I'm going to do 3 plus 5 plus 11 minus 15. So that will all add up to 4 if we take the time to do that. And then finally, negative 4x squared minus 2x squared. Negative 4 minus 2 gives us negative 6x squared. So I've taken my like terms and I've combined them using addition or subtraction. And I'm just going to highlight these again to show where those pieces came from. Let's see, grab my green highlighter. Okay, so now we've combined them. Our next step is to rewrite that in order from largest exponent to smallest. Whoops, largest exponent to the smallest exponent. So since our largest exponent is a 2, right, that x squared, that's going to go first, negative 6x squared. It doesn't matter what's in front, just the exponent. Then negative 21x, because it's an x, and its exponent is really a 1. And then finally that positive 4 at the very end, because it doesn't have a variable. So with some practice, that middle step where we're listing it out and combining it may not be necessary, but for right now, I'm going to have you take a look at this example here. You try. I'm going to have you try that on your own. So I would pause the video here and come back to check when you're ready. All right, welcome back. So looking at some of your like terms, I hope that you identified x, 2x, negative 3x. So when we add that up, x plus 2x minus 3x makes 0x. And then we've got negative 9 minus 2 minus 4, which adds up to negative 15. And then our last set of like terms is x squared plus 2x squared minus 3x squared. I got that from those last remaining little bits there. And that again makes 0x squared. So if I'm rewriting this in order from largest exponent to smallest exponent, that would be 0x squared plus 0x minus 15. But you may be remembering, wait, Miss Wombold, 0 times anything is just 0. So if that's the case, then really this simplifies to simply negative 15. So with combining like terms, it's possible that everything will cancel out completely. So if you got to the 0 terms with a 0 in the coefficient, that's great. If you manage to simplify it all the way down to negative 15, even better. So let's talk about what this might look like with polynomials. Again, those expressions that are using coefficients and variables and addition and subtraction. So in this example, first example, 3x minus 2x squared plus 6, that is a polynomial. It's kind of one set. Then we're adding to it another polynomial, 5x squared plus x minus 11. Those parentheses are just there to identify the two separate polynomials. If we think about what's really in front of those parentheses, there's ninja ones. If I distribute ninja ones, well, nothing actually changes. I'm just left with the same expression, but without the parentheses. So I'm just going to rewrite that, and all of a sudden this looks like my examples from before. I'm just combining or identifying like terms. So I'm going to combine my 6 with my negative 11 to make negative 5. I'm going to combine my 3x and x to make 4x. Whoops, using the pen there. Come on. 4x. Oops, now I'm just making things worse. Back up. And then finally, I'm going to combine the negative 2x squared with the 5x squared to make 3x squared. So I did multiple steps in one here. I'm looking for what are my like terms and combining them automatically. Obviously, you can do this in multiple stages where you're actually listing things out if you still need that visual. Do be careful with your like terms. It's easy to accidentally combine an x squared with an x. So for this next example, we'll do this one again together. If I'm just thinking about a ninja one that's getting distributed, it doesn't actually change any of those values. I still get 5 minus x squared plus 4x minus 9 plus 2x squared. And again, this time I'm going to start with my x squareds because I can. So negative x squared plus 2x squared makes a whopping 1x squared. And then my x term, because that'll come next, negative x and 4x combine to make a positive 3x, so I'm going to put plus there. And then finally, 5 and negative 9 will combine to make negative 4. So again, I've got all those pieces combined. I've got it written in order from largest exponent to smallest exponent. And I'm doing multiple steps in one. If you need to break those steps down further, please do. I think now's a good time for you to try an example on your own. So take a look at this example, pause the video, and come back when you're ready to check. Welcome back. So once you rewrite this without the parentheses, you distribute those ones, you get something that looks like this. And once you identify your like terms and put them together, you'll actually get 0x squared plus 0x plus 0, which simplifies to 0. You guessed it. So if your final conclusion here was 0 and wondered what you did wrong, you're actually on the right track. So besides adding polynomials by combining like terms, we can also subtract polynomials. Oops, that's supposed to be a highlighter. My apologies. We can always subtract polynomials here. So subtracting polynomials, as it turns out, is exactly the same as adding polynomials. It's exactly the same as adding polynomials, except that we're going to distribute a negative 1 as the minus. So we're going to distribute a negative 1 to represent that subtraction, to subtract. So the examples here, so that first polynomial doesn't have anything in front of it, right? That's still just a positive ninja 1. When I distribute that, it's just 14x plus 4 plus 3x squared. Multiplying by 1 doesn't change anything. But in my second polynomial, multiplying by negative 1 changes the signs in all of them. So negative 1 times 6x squared is negative 6x squared. Negative 1 times negative 5x makes positive 5x. And negative 1 times positive 8 makes negative 8. So it's kind of one more thing to think about, but multiplying by negative 1 should be okay. So from here, I'm going to repeat the same process where I'm looking for like terms. So I've got my squares, 3x squared, and negative 6x squared makes a negative 3x squared. And then I'm going to look for my x's. X over here, 14x plus 5x makes a positive 19x. And then finally, my constants, my terms without variables. So 4 minus 8 makes negative 4 as my constant at the very end. So again, a very similar process. All we did here was make sure that we were distributing a negative 1. So let's practice over here with the second example. Distributing a positive 1, we get 7 minus 4x plus 11x squared. So I'm going to rewrite that. And I really encourage you at this point to be rewriting these. Eventually, you may feel confident doing this in your head, but for right now, these are really easy mistakes to make, especially with this negative 1. So do take the time to just multiply it out and rewrite it. Negative 1 times 3x makes negative 3x. Negative 1 times negative 2x squared makes a positive 2x squared. And negative 1 times 9 makes a negative 9. So, oops, I made a mistake here. Maybe you caught it. When I was rewriting my 11x squared, I rewrote it as 11x. That's kind of a big deal there. So keep an eye out. Like I said, it's really easy to make those mistakes. So double check, pay attention to what you did in there. Now that I've got it all ready, I'm going to start with my squares. That 11x squared and my 2x squared make 13x squared. Oops, 13x squared. And then my x's, I'm going to have negative 4x minus 3x makes negative 7x. And finally, my constants, my terms without variables, positive 7 minus 9 makes negative 2. So don't rush through these like I'm trying to, right? Take your time, rewrite everything carefully, and just double check. And if you notice, when you're checking your answers later that you made a mistake, it doesn't mean that you don't know what you're doing, right? It could possibly mean you forgot to put a square on something. So there are a couple examples down here for you to try. Looks like 1, 2 more examples here. So I'm going to have you pause the video, try these out, and come back when you're ready. All right, welcome back. We're just going to double check these two, make sure you're good. When you distribute and rewrite, you should get 2x squared minus 3x plus 6 plus 5x squared minus 9x minus 4 minus 8x squared minus 12x. So all of those should have a negative sign in front of them. And when you combine all of your like terms together, you should get negative x squared minus 24x plus 2. So double check, did you identify all of the like terms? When I say negative x squared, that's also negative 1x squared. So just a little simplification there. This second example, you might have noticed you had to distribute a couple things and distribute some, or not distribute. So that first polynomial has a 1 in front, so we'll rewrite as 5y squared plus 4y to the 4th plus 3y to the 3rd. That second polynomial has a negative 1 in front of it, but be careful, I'm only going to distribute until those parentheses, because that's the one that's being applied with that negative 1. So I get negative 6y squared minus 8 plus 7y to the 3rd. Because this last polynomial, it's a little polynomial, but I'm actually distributing a positive 1, not a negative 1. So those signs get to stay exactly the same, 11 minus 6y cubed, or to the power of 3. So we've got some different variables here going on, but I'm looking for, what is my largest exponent? My largest exponent in this case is a 4, and it doesn't have anything to combine with. So I'll just have 4y to the 4th out in the very front. And then my power of 3, I have 3y to the 3rd plus 7y to the 3rd, which makes 10y to the 3rd. And now I can look at my squared, 5y squared minus 6y squared. Oh, did you catch my other mistake? Yeah, I forgot a cube there. You're saying it's not supposed to be 10. If I subtract that 6y cubed, I'll get a 4y cubed. So what did I say about being careful and taking your time and checking your work? That's exactly what I meant. Okay, but now if I have 5y squared and minus 6y squared, that's negative 1y squared. I could just write that as negative y squared. And then finally my constants. Negative 8 plus 11 gives me a positive 3. So one of the reasons I like writing this out is so that, and highlighting and marking is that if I had gotten to the end and I still had this negative 6y cubed, okay, that's easier for me to sort out than if I'm not making any marks at all. So thank you for watching. Go ahead and check out your practice assignment. The answer key is on Canvas, but remember, check with a neighbor first. Work together with your practice. You guys have a lot of great people in the room with you. Use them and have a wonderful rest of your day.